Hello and welcome to the bookshelf. Today I'm going to explain to you what are machines, their types, and also what are levers, their types, and the law of the lever. Let's go! When asked about what is a machine, the first thing that will surely come to your mind would be something like a dishwasher, a robot, a car, and that's true. They are machines, but machines aren't necessarily as complicated as these ones. Machines can be as simple as a wedge or a ramp. We'll see it in this video. The definition of machine is a set of mechanisms coordinated with each other to perform, from an input energy, a useful work or an energy transformation. Knowing that, let's take a look at the two types that exist. And they are simple and complex machines. Simple machines are basic mechanical devices that do not have moving parts and are usually used to multiply or change the direction of a force. For example, scissors or levers. Then, we have complex machines, which are machines made up of two or more simple machines working together to perform a specific task. For example, clocks or planes. Now, let's take a look at the levers. A lever is a simple machine consisting of a rigid bar that can pivot around a fixed point called the fulcrum. Levers are used to lift, push, or pull objects with less effort. Knowing that, we can divide levers in three classes: first class, second class, and third class. Now, let's take a deeper look at each class of lever. First of all, something that all levers share are their three components: the load, also referred to as resistance or output force, the fulcrum, also called pivot point, and the effort, which can be named as input force or simply force. In this case, first-class levers, we will always observe that the fulcrum is in the middle and the load is, on the other side, respect the effort. A seesaw is a first-class lever. This is the clearest example, because we can see that on each side we have somebody applying a force, and in the middle, obviously, we can observe the fulcrum. Let's take a look at second-class levers. In this case, the fulcrum is at one side of the lever, the load is in the middle, and the effort is on the other side. A wheelbarrow is a second-class lever, and that's because the wheel is the fulcrum, the content is the load as it weighs, and the effort is applied by the person who moves it. Finally, we have third-class levers, which consist of the fulcrum at one side, the effort in the middle, and the load on the other side. A fisherman using his fishing rod is a third-class lever, as the fisherman's body is the fulcrum. The effort is applied in the middle, the fisherman's hands, and the load is the fish trying to escape. Having checked what levers are, let's take a look at the law of the lever, which can be stated mathematically as F1 times D1 is equal to F2 times D2, where F1 is the force applied to the lever. D1 is the distance from the fulcrum to the point where the force is applied. F2 is the force exerted by the lever, the load or resistance. D2 is the distance from the fulcrum to the point where the force is exerted, the load. To understand it better, let's take a look at an example. In this case, we can observe two people playing on a seesaw. Knowing the law of the lever, we can instantly differentiate between the different components of the lever. F1, the effort, F2, the load, the fulcrum, the distance between force 1 and the fulcrum, which is D1, and the distance between force 2 and the fulcrum, which is D2. Let's take a deeper look into this example. Imagine that the man weighs 80 kilograms. The woman weighs 70 kilograms. The distance between F1 and the fulcrum is 2 meters, and the distance between F2 and the fulcrum is unknown. To discover D2, we'll have to apply the formula. First of all, we isolate D2. After that, we substitute each component by their value. And finally, we calculate it, and approximately D2 is equal to 2.29 meters. I hope I have explained myself properly, so that you know now what are machines, what are levers, their types and the law of the lever, and how to apply it. As it's my first video, I would be very grateful if you can comment anything for me to improve, and I surely will. That's it for today. If you have enjoyed it, I would appreciate if you can leave a like and subscribe. It will help me grow and continue creating videos. Thanks for watching.